Alright, so welcome to another segment of my mathematics videos as we look at this time quadratic functions. Remember, a quadratic function is written always in the form f of x is equal to ax squared plus bx plus c. So that is what you need to remember. So now this is what we are calling as being a quadratic function. Remember the coefficients. If you look at the coefficients of x squared, that is a, and the coefficient of just x is positive b, include the sign in front, and we do have what we are calling as being a constant, and that constant is c, just any number that you have. So now what you need to remember is that when you have got a quadratic function, for example, this f of x can be represented by y, and therefore we can say that y is equal to ax squared plus bx plus c. So that is what we can say. Now I want you to remember a few things that you can have. So when your a, let me talk about the shapes that are formed, which we call the parabola. So the shape formed by a quadratic function is simply called as being a parabola. So now there could be two main shapes that you're going to be finding in your paper one. So if your a is actually greater than 0, we mean that it is actually positive. So if your a is greater than 0, it is positive, then the shape of the graph that you're going to have is going to look like that. But on the other hand, if your value of a in that function is less than 0, I mean it is a negative number, it simply means that you're going to have your curve facing in that direction. So when our a is greater than 0, meaning it is positive, we are going to have where the curve is turning, we call that one as being the turning point. So we call that one as being the minimum. So this is what we call as being the minimum turning point, sometimes referred to as the TP. So the minimum turning point, you have the value of x at that point, and you also have the value of y. So you have a minimum TP. But if your a is less than 0, meaning that it is negative, it simply means that your turning point is going to be a maximum. So you're going to have a maximum TP, turning point. Again, you are going to have the value of x at that point, the value of x, and the value of y. In fact, if you remember the value of x, because they are going to tell you it will be like a line of symmetry. So they are going to tell you to actually find the line of symmetry. So now it is easy for you to know, the line of symmetry. Let me just give you some ideas. For you to get the line of symmetry, in this case, the value of x, if you know where the curve is cutting, the x-axis. For example, if the curve is cutting the x-axis, let's say at point x1 and at point x2, and you want to know the line of symmetry, which is the value of x at that turning point, whether it's minimum or maximum, what you do, you just add the two values, x1 plus x2, you divide that one by 2. But as I'm going to show you, there's also another method. Alternatively, we can also use what we call negative b over 2a. So using that can help us, where b, a are simply the coefficient in that quadratic function that we have. All right, so let me give you some more ideas there so that you are able to see exactly what we need. So now sometimes they can ask you, so whether the curve is it has given you, you have got a minimum turning point. So you have got a minimum, you have got a minimum turning point, or you have a maximum turning point. Remember we said when a is greater than 0, but here when a is less than 0, meaning your turning point is actually going to be a maximum. So you can find the coordinates of the turning point. How do you get the coordinates of the turning point? But there are so many methods that you can get the coordinates of the turning point. So for you to get the coordinates of the turning point, what you can simply do is that, remember, the coordinates of the turning point consist of the value of x and the value of y. So to get the value of x, you simply can use negative b over 2a, comma, to get the value of y, which is either the maximum or the minimum. What you do, you can use the formula, 4ac minus b squared over 4a. So you can use that, but I'm going to show you different methods that you can use in order for you to actually carry out that. So that is what you need to remember. So when you replace, but where are we getting this? Remember, these values are coming from, they are coming from coefficient, your a, your b, and your c. So those are the values that are found in this one. So you can use that to find the coordinates of the turning point. Let me just show you how you can quickly, go about that. Let's look at some sample questions so that you are able to see how you can go about that. So with me, I've got some sample questions here that we can use. So according to the first one there, and let me use also a different marker. It says the sketch shown below represents the graph of a curve y is equal to x squared minus 4x plus 3 passing through the point A, B, and C. A, B, and C there. All right, so that is what you need to remember. Now, just a few concepts. Maybe let me just take you back slightly. Sorry for that. Let me just take you back. This is very important. If you have your x or y plane, so if you have your x or y plane, remember that along the x-axis y is always 0, and along the y-axis, remember that x is equal to 0. So if you want to find any coordinates along the x-axis, y should always be equal to 0. So that's what we mean. So if you want to find, for example, they have given you the coordinate a and b, it simply means that y is equal to 0. If you want to find the value of x along the x-axis, and there, if they have given you, x is equal to 0. So to find the value of y where it is cutting, it simply means that you need to equate your x equal to 0. So that is a very important concept that you need to remember under quadratic function. You'll be using that expression. So now let's look at the solution there. So after telling us that, the question says find the coordinates of the point B and C. So how do we get the coordinates of the point B and C? Remember, B and C are along the x-axis, but we know that along the x-axis y is equal to 0. So I'm going to say when y is equal to 0, what are the values of x, so that I can do that. So this, you get the equation that is making the curve y is equal to x squared minus 4x plus 3. So where there's y, you replace 0 is equal to x squared minus 4x plus 3. So remember what I told you, you need to find the product. This can also be written x squared minus 4x plus 3 is equal to 0. We want what is having terms to be on the left-hand side and numbers left on that side. So from there, we can identify what our a is, the coefficient of x squared, which is 1, and what is our b, the coefficient of x, negative 4. Please remember even to take the sign in front, very important. And our c is a 3. So what do? We can get the product sum and the factors there. So what is our product? 1 times 3 is a 3. The sum is b, which is negative 4. What are two numbers? When you multiply, they'll give you 3, but when you add, they'll give you that. It will be negative 1 and a negative 3 there. So remember, you write these in terms of x. So it will be negative x, and that will be negative 3x. So what do? We now replace the middle term and factorize. So it will be x squared. So we replace the middle term, it will be minus x minus 3x. Then again, we bring in the last one, which is a plus 3 is equal to 0. So you group them and you factorize. What is common there is x. If I divide x there, I'll remain with x. If I divide x there, I'll remain with 1. Please, the negative there, bring it out. And the 3 is also common. So if you divide negative 3 there, I'll remain with x. If you divide negative 3 there, you have a negative 1, which is equal to 0. You can see what is in the bracket is the same group what is outside. So it will be x minus 3 then what is in the bracket x minus 1 is equal to 0. So equate each bracket to 0 there. So it will be x minus 3 is equal to 0, meaning x is equal to a positive 3 when this goes the other side. Or x minus 1 is equal to 0. When this goes the other side, when the negative 1 crosses the equal sign, it becomes a positive 1. So now once you do that, it simply means that we can get the coordinate. Remember, numbers going this side are increasing. So which one should be b and which one should be c? Of course, this should be smaller and c should be greater. Therefore, at b, x is equal to, we can say here that x is equal to 1, and at c, x is equal to 3. So the coordinates at b will be, when x is 1, remember our y is 0 along the x-axis. And what about c? It will be 3, 0 again. So these are the coordinates that they wanted us to get in this case. All right? Very important. Okay. So now, how do we tackle now the minimum value of y? Well, the minimum value of y is not complicated. It is something very simple that you can actually deal with. How do we get the minimum value of y? Well, there are so many ways, like I told you, that you can do. But let me show you the first method that I'm going to look at. So question number 1, Roman 2 there. How do I find the minimum value of y? So you can find the x coordinate of the turning point. So how do you get the x coordinate of the turning point? Remember what we said, you can simply say you add the two x values that you got, you divide by 2. So x is equal to, so you can get this one, 1 plus 3, you divide by 2. So x is equal to 4 divided by 2, which is equal to 2. So once you get this one, you can know the value of y, which is the minimum value of y, because it is turning. Remember, it is facing upward there. So you get that equation, x squared minus 4x plus 3. Then you replace this value into that one. That will help you to know what we are calling as being, the minimum value. So it will be y is equal to x is 2 raised to the power 2 minus 4 times 2 plus 3. So y will be equal to, that will be 4 minus 8 plus 3. That is negative 8 plus 3, that will give us negative 5. And what is 4 minus 5? It is negative 1. So this is the value of y, the minimum value of y that they wanted you to get. So you can use this method in order to do that. It is possible that you are able to do that. Remember again what I told you. Alternatively, I can also find that one. Okay, just hold on so that you are able to see. Let me show you another alternative method that you could actually use to get the minimum value of y. Okay, so alternatively, I can simply say alternatively, remember we said y is equal to, you can also use the minimum value, which is the value of y, can also be 4ac minus b squared over 4a. But where are we getting the a and the b? It's from the equation that we were given. Remember, our a is simply a 1, our b is simply a negative 4, and our c is simply a 3. So let's try to see if we can replace there. So it will be 4 times, what is our a1 and what is our c, which is a 3, minus what is b, it is negative 4, but this raised to the power 2 over 4 multiplied by 1. So that's what we mean. So it will be y is equal to 4 times 1 times 3 will give you a 12 minus negative 4 raised to the power 2 give me a positive 16 over 4 times 1, which is a 4. So what will that give you? Okay, let me just write it this side. It will be 12 minus 16 is the negative 4 divided by 4. So therefore y is equal to negative 1. And that's why I gave you that. So it's possible you can use it to find the minimum value or even the maximum value. You can simply use the same. There's actually no problem as long as you know what your a, your b, and your c represent in that expression. All right, let's move on to question number 2, which is my last question that I'm actually looking at. So according to this question there, it says that the diagram below shows a sketch of a graph which meets the x-axis at, so it meets at -4 and a 2. Find the equation of the graph. So the question there is now asking you to find the equation of the graph. So now how do you find the equation of the graph when you have been given where it is cutting the x-axis? It's very simple. Remember the two values. This is x is equal to -4 and the other value is x is equal to 2. So to find the equation of the graph, just bring these ones this side. It will be x plus 4. That's what you're going to have is equal to 0. This one, that side, when it goes this side, it will be x minus 2 is equal to 0. So my interest is for you to get this and you get that and just multiply them. So it will be y, the equation will be get this bracket x plus 4 and get this other bracket x minus 2. So this is actually the equation that is making the equation of the graph there that we have there. So there's nothing, really complicated. Then it says the coordinates of the turning point. Remember what I told you, the coordinates of the turning point? Let's do it from the top there. 1, you can actually find, you know where the values it's cutting. So you can find the x coordinate of the turning point by adding the 2x values divide by 2. So that is going to be, you have -4 plus 2 there, then you divide by 2. So x will be -4 plus 2 is -2 divided by 2. So therefore the x is equal to -1. So where this curve is turning, x is equal to -1. So therefore what I'm going to do now, this equation that we have found, we are now going just to replace x plus 4 and x minus 2 to know the coordinate of the turning points. I need to know the value of y. So x there is -1 plus 4, and the other one will be -1. Remember this is x, so it will be -1 minus 2. So y will be equal to, that will give us a +3, and that will also give us a -3. So y will be equal to 3 times -3, that will be -9. That's what we mean. So that's the value of y. So meaning the coordinate, therefore the coordinate of the turning point will be x is a -1 and y is simply a -9. So these are the coordinates. That's the way you can find them there. All right? Yeah, so it is possible. But if you expanded this one, you could have also used that alternative method where I told you to find the coordinates of the turning point, -b over 2a, then 4ac minus b squared over 4a. As long as, first of all, you need to expand that so that you can identify your a, b, and your c, then you'll find that you're going to get the same value. Thank you so much. Watch out for my next videos.